this training is for people who wants to make their career in Docker and Kubernetes. If you are a developer, this course gonna help you out. First thing. The second thing is that if you want to be administrator, like if you are like cloud administrator or solution architect, right? So again, this course gonna help you out to troubleshoot your cluster. This is the mix up of two courses, CKA and CKAD, right? After completion of this training, you can attend any one of the certificates as per your requirement, right? So see, first of all, this course, how it gonna help. So this will be helping you if you want to become a DevOps engineer, right? Or if you are a developer, this course is gonna help you. If you are cloud administrator or cloud engineer or cloud architect, right? This course is suitable for all of you because, like even if you are a cloud architect or DevOps engineer, right? So just take these scenarios. So if you are cloud architect, so obviously you might be creating infrastructure, you might be troubleshooting, right, with volumes and VMs, all the cloud environment, correct? So these days, cloud providers are providing Kubernetes. For an example, AWS is providing EKS, Elastic Kubernetes Service. Azure is providing AKS, Azure Kubernetes Service, and Google is providing GKE, Google Kubernetes Engine, right? So again, you will be responsible to create and configure these cloud Kubernetes clusters or environments, right? If you are already aware of Kubernetes, then it will be easy for you to deploy the cluster and manage and troubleshoot it. If you are a DevOps engineer, so obviously you're gonna containerize the application and you will be deploying your containerized application in Kubernetes. If you are having very good knowledge or idea about application containerization, so this will help you to troubleshoot your deployed application in Kubernetes environment, right? So this is the thing. Who am I? So guys, my name is Manish. I'm certified Kubernetes administrator as well as I'm certified Kubernetes security specialist. I works on all kind of Kubernetes environment. Okay, whether it is AKS, EKS, GKE, or including OpenShift, right? So currently I'm just freelancer. This is my part-time thing that I like to train people on Kubernetes. So that is the reason I'm here to train you, right? Now, the main important thing about Kubernetes is the prerequisites, right? It's very interesting, very first of all. If you know basic of Linux, how to create the VMs on any cloud, whether it is AWS or Azure or Google, right, GCP. So it will be easy for you to create Kubernetes cluster, manage, troubleshoot it, because every time you will be dealing with Linux machines, Linux server. Knowledge of cloud is a plus. It's gonna help you again to create your environment. Writing YAML file is very important because whenever you will be doing deployment in Kubernetes, so you will be writing your deployment configurations in YAML, right? If you don't know YAML file, that's perfectly fine. I'm gonna tell you while starting writing, this Kubernetes YAML file. Virtual box for offline setup to do the lab setup. Basically, I will be helping you how to set up the lab on your personal laptops by using VirtualBox. If your laptop is having really very good configuration, 16 GB RAM and a good CPU, this will be helping you to have your lab offline. You don't need to pay anything. If you are going with cloud Kubernetes or cloud labs, 100% charges will be there. But again, you no need to worry about it that if you don't have cloud account, you don't want to spend money on the cloud, or if you don't want to spend money on your laptop, right? Basically, if your laptop is not very good on configurations, so I will be providing you some of the free labs. So forget about it. Be relaxed. I'm gonna help you on these things, setting up the lab environment. So guys, course objective. Let's discuss about course objectives. What all things we are going to learn. So basically, we will be starting with Docker, basics of Docker from the scratch, and slowly we will be moving forward to advanced topics, right? So exactly Docker is its architecture, right? How Docker is different with virtualization, and we will be comparing these things: virtualization, on-prem to virtualization and virtualization to containerization. How these things are different from each other, why containerization is being adopted these days. That's the thing that we will be discussing in our training session. And what exactly a Docker is, how it works, what type of volume Docker containers is having, right? How container is different with the VM, right? So how memory and CPU is being allocated to the container on the runtime, correct? How you will be creating Docker images, how to containerize your application by writing the Docker file, right? Uh, Type of images we will be discussing about that, and we'll be writing our own Docker file to create the Docker images. How we can limit resource utilization on the container, what exactly Docker composes. All these things we will be discussing. Before starting with Kubernetes, we will be having a small a discussion, differences between Docker Swarm and Kubernetes, why people are not choosing Swarm, why people started adopting Kubernetes, right? So a deep discussion will be there once this topic is started. And before proceeding further, I'm having one of the text document here that is having detailed information about course content. You guys see here, Docker. That's fine. Docker is your container runtime interface, CRI. But the thing is that Docker is not alone these days as CRI. So we are having Cryo, we are having Podman, we are having Containerd. Many competitor of Docker. Docker is available in market. Which one is being adopted these days? So see, direct support, Kubernetes dropped to the Docker because it started supporting all other type of containerization tools like Cryo and Containerd as well. Containerd basically is in use, it is being used by most of the cloud provider, EKS, AKS, GKE, like containerd will be there. But Cryo is the more secure container runtime interface, which is being implemented in OpenShift. What is this OpenShift? OpenShift is nothing but a product of Red Hat, which is created on top of Kubernetes. Whenever Kubernetes is releasing a new version, so OpenShift is adopting and they are releasing their own upgrade. Now, in result of this, if you are able to work with Kubernetes, 100% you will be able to work with OpenShift as well. Differences between them. Kubernetes, including all cloud Kubernetes variants, AKS, GKE, blah, blah. This comes up with CLI, okay? Command line interface. OpenShift comes up with GUI, graphical user interface. It's easy to operate, but whatever thing that we are going to learn here in our current sessions, right? Things will be as it is in OpenShift as well. You might be seeing few advanced feature and functionality available in OpenShift. Let's come back to the Docker again. We will be installing and configuring Docker in our virtual machines. We'll be learning that, how containers are being created, what all its components are, right? A client, a Docker server, registry, a Docker image, Docker container, where Docker is storing data on the host machine, right? Union file system, how it works, right? And image layers, and after that networking, how this is something. Okay, this we are not going to do few things here, few of the basic things that I seriously don't want to do this one because unnecessary the theory will be there. So types of network we will be talking here, like host network, bridge, null, overlay, MacLAN. What all type of networks are available in Docker that we are going to discuss. How container to container communication is being enabled. How one container is communicating to one container, right? What type of mechanism it is using, and we will be implementing it practical by having two front end back end containers. They will be communicating to each other, right?
So now see the storage, right? Docker storage, what type of Docker storage we are having here available, like, bind mount, volume mount, tempfs. What exactly these things are, we are going to learn about these things, right? And if you see here, image, container, Docker, application data, how all those things are being stored in your virtual machine that we will be exploring. We will be writing our own Docker file to create a custom Docker image. In simple word, we will be learning application containerization here. Okay, application containerization. We will be doing it here, building custom images and all. These things will be here. And what else to see here? Type of registries, we are having different type of registries, so we will be exploring hub.docker.com and GitHub to store our Docker images remotely. Local registry has been deprecated, it's gone. Docker Compose, we will be learning about Docker Compose and even how to start multiple container at single go. And again here Docker machine is being deprecated, it is gone. Right, we will be just theoretical part. We will be looking about Docker Swarm, how what exactly it is, how it is different with Kubernetes. Small things we will be learning about Docker Swarm, theoretical part, and the most important thing is deployment of application like Nginx. Instead of MariaDB, we'll be using MySQL and WordPress on your Docker Compose file, right? And deploy WordPress web server, same thing it is written, twice. Deploy application with custom Docker file. Yeah, that's what we will be learning about. The task that above given topics we will be implementing. YAML file. I will be giving you introduction about YAML, how to write YAML file, what all possibilities are there about object, and tutorial for YAML that I will be doing it here. Kubernetes deep dive, it starts from this place. So what exactly Kubernetes is, how to create Kubernetes cluster, what all component it is having, right? Each of the components responsibility, the job of each of the content, why these contents are here. We will be learning about them. We'll be forming the Kubernetes cluster from the scratch by our own, by installing each and everything manually, So control plane components we are having here like Kube API server, controller manager, Kube scheduler, core DNS, etcd, kubelet, kube proxy, and your CRI, container runtime interface. Any one of them we will be choosing while forming the Kubernetes cluster, right? So Flannel is being deprecated. Again, we will be using Calico. VNet is also deprecated. Few contents, got deprecated from this course content is older one. I'll be updating it. You don't need to worry about it. Compute nodes means worker nodes component. We will be talking about them as well. What these components are doing, what is the use of these components on the worker node. We'll be exploring each and everything while forming the cluster, right? And after that, pod object, what exactly pod is, how many container can be created inside the pod, how to enable communication in between two containers while being inside the pod, or pod to pod communication, container to container communication, right? That we are going to explore here, right? We understand common networking, common storage in pod, how to share data in between containers within or in a pod, right? How it will happen, that we are going to explore it, right? Multi-container deployment, like different type of methods we are having to keep your application inside the pod. How you will be achieving microservice architecture, and how monolithic applications deployment can happen inside the pod, right? That we will be exploring later on. Type of pod, static pod, simple pod, and then static pod, init containers, what exactly those things are, that we will be exploring about it. And application deployment using registry repositories, private repositories, how to limit, not allocation, allocation is not the word. So basically resource limitation like CPU memory on each of the container, how we will be dealing with this, how to replicate your containers in your Kubernetes cluster, what all objects we can use, like a replication controller, we can use a replica set, right? A deployment object, what exactly it is. So deployment object is the main object which will be used, or people are using in projects to deploy their application. It is really very good object that gonna help you to achieve highly availability, and it will help you to perform rollbacks. It can help you to check the deployment histories, when rolling update was performed, when somebody rolled it back. everything will be mentioned or discussed while discussing about these objects. Deployment is the main one. What is a daemon set? Daemon set gonna help you to deploy your logging monitoring application in the cluster based on the nodes, number of nodes, right? So this is one thing. Stateful set is something which will be helping you to deploy cluster inside cluster, MySQL cluster, or Hashiko Vault cluster, right? Or Kafka cluster, how these clusters are being deployed in Kubernetes by using stateful set. What is the feature and functionality stateful set comes up with? Headless service, your cluster IP service, right? So how it works with those things, we will be discussing about it. Different objects we are having here, and we are having volumes, persistent volumes. So persistent volume is something which will be helping you to persist or permanently save data on your containers. Basically, if your container is being crashed, so whenever your container is coming back up and running again, so how it will be getting the previous data through persistent volumes, right? What exactly PV is, PVC is, empty directory is, host path is, right? We'll be discussing about these things in very detail. Type of services, to access your application outside of the cluster or within the cluster. Type of communication through services we will be exploring, like cluster IP, node port, load balancer, and external IP. There's many things we are going to discuss about these things. After that, secrets and config map. What exactly secret is, what is config map, how you are going to store your passwords, username, and certificates inside the secret object, that we'll be learning. Config map will be helping you to store your configurations in centralized place and call in different deployments based on your environment, that we are going to explore. Secret and config map is something which can be used in two ways. Number one is in environment variable, and number two is in form of files with the volumes. How you can implement these things is quite interesting topic, which you gonna explore in your day-to-day activity you will be doing in your workplace. Definitely, if you're joining as a Kubernetes guy in any of the projects. So these are the mandatory things. Ingress controller. So again, ingress controller will help you to access your application outside of the cluster, but based on the domain names like google.com, facebook.com, how your application is being deployed inside the Kubernetes and how you'll be accessing your application based on domain names outside of the cluster, right? So this ingress controller comes into the picture. We will be exploring about Nginx ingress controller. Is something very important, widely used in most of the projects, right? Horizontal pod auto scaling, how your application will be doing auto scaling dynamically if minimum number of pods are not able to serve the traffic, then how HP comes into the picture to achieve high availability by adding additional pods in your Kubernetes cluster, right? This is what your HPA is. Scheduling and probes. Wow, it's very complicated, confusable, and important topic for interview purposes. Sometimes projects are not using, but for interview it is super important. Interviewer gonna ask you these things on very high priority. Scheduling means what? You will be having multiple nodes available in a cluster. How your pod will be scheduled based on the node name, based on the node labels, right? Type of achieving affinity, anti-affinity, taint toleration. There is many things that we will be going to cover in this part, scheduling. Probes are nothing but gonna check the health of your containers running inside the pod, right? How to check the health, like readiness, liveness, that we are going to explore it. Probes. Job, what exactly job is, and cron job is run job on like Kafka queue or something, like taking the backup, or cron job is something to schedule or execute pod on the given time, right? The most important part here is RBAC. What exactly RBAC is? Authentication and authorization, that we are going to learn about it. we'll be creating the user. Let's say we are working in a team. So I'm the administrator. A few of my colleagues might be like juniors. So based on their roles, we will be giving them cluster access by implementing rule and role bindings. Cluster role binding. That will be also covered. Kubeconfig file, what all things it contains, right? Service accounts, right? And we will be authenticating our user through certificates, right? GUI part in Kubernetes is nothing but a simple dashboard. Kubernetes having that I will be deploying in front of you, and I'll be demonstrating it how to access it. What exactly it is, right? So again, front end, back end example will be here. Cluster upgradation will be here. ATCD backup will be here, and what is chart? So Helm chart will also be there in. Okay, that's fine. Helm chart will be there. We will be learning about Helm chart as well, how to create your own custom Helm chart and how to store it on remote repositories. That's what I will be going to teach this thing to you. Cluster upgradation, I told you, right? Yeah, we will be doing that. Here, like a few things is deprecated, few things are here and there. I'll be arranging everything on the sequence. And you can see that somewhere I see this was 1.20.1, right? We are obviously not going to use this older version of Kubernetes. These days, we are having the latest version of Kubernetes, which is 1.32 or 3. I'm not sure. Kubernetes.io. If you open this website, so the versions you can check it out 33. Version 1.33. So I will be creating cluster by using 1.32 or 31 something, and we'll be updating it to 33. Or if you are creating cluster on 31, so 32. That's all, right? So latest thing we are going to use, we will not be using any older things which is already deprecated. So yeah, this was all about course content, guys.